Hello, my dear students. This is again Teacher Jenny guiding you on our third module for Quarter 3 of Statistics in Research 8 with the topic, the median and mode of grouped data. So at the end of this video, you are expected to determine the median class and modal class of a given grouped data and calculate the median and mode of grouped data. Last time, we had discussed on the different measures of central tendency. Can you still remember them? Nice. What are those? Very good. We have the mean, the median, and the mode. And take note that there are two main types of data. We have the grouped and the ungrouped data. And we've already discussed on finding the measures of central tendency for ungrouped data. Then on our previous video, we had discussed in finding the mean of a given grouped data. Because if you can still remember, we cannot use the formulas or steps or ways in finding the measures of central tendency for ungrouped data with that of grouped data. So this time, we will discuss on the other two measures of central tendency, the median and mode of grouped data. Now observe these two formulas. Which do you think is the formula for the median of a grouped data? Very good. It's the formula on the lower right. It's this one. This is the formula for the median of grouped data. And of course, the other formula here is the formula for the mode of grouped data. Now, let's have the median of grouped data. Take note, when we say median, it's the middle value of a given data. So to find for the median of a grouped data, we use the formula MD is equal to LB sub MC plus summation of F over 2 minus less than CF all over F of MC times I, where MD represents the median, LB sub MC is the lower boundary of the median class, the less than CF is the cumulative frequency of the lower class next to the median class, the F sub MC is the frequency of the median class, and I is the class size. Let's have an example. We have here the weight of students. So what we're going to do is to find for the median of this given grouped data. To do that, first we have to complete the table. Starting off with the value of the class size. If you can still remember, in finding for the class size, we simply have to subtract the upper limit minus lower limit plus 1. So that's 15 minus 11 is 4 plus 1, so we have 5. Or you can just count manually the numbers belonging in each class interval. So say for example, in the class interval 46 to 50, we have 46, 47, 48, 49, 50. There are 5 numbers included on the class interval. Therefore, the class size is 5. Now, for the total frequency or the summation of F, we simply have to add all the values under the frequency column. So that's 7 plus 6 plus 9 plus 7 plus 6 plus 3 plus 0 plus 2, and that gives us 40. Now, for the lower boundary, we simply have to use the formula LB is equal to LL minus 0.5, or the lower boundary is equal to the value of the lower limit minus 0.5. So for the class interval 11 to 15, we have the lower limit 11 minus 0.5, that is 10.5. For the class interval 16 to 20, we have 16 minus 0.5, and that's 15.5. Next, we have 21 minus 0.5, that's 20.5. Or, to find for the succeeding lower boundaries, we simply have to add 5, or the value of the class size, to the preceding lower boundaries. So that's 20.5 plus 5, that's 25.5. Plus 5 is 30.5, plus 5 is 35.5, plus 5 is 40.5, then plus 5, we have 45.5. Now, for the less than CF column, you may start with the class with the highest class interval. That's 46 to 50. Its less than CF value should be equal to the value of the summation of F, since it's the highest class interval. So we have 40. To find for the succeeding less than CF, we simply have to subtract the less than CF minus the frequency. So that's 40 minus 7, it's 33. 33 minus 6 is 27. Minus 9, it's 18. 18 minus 7 is 11. 11 minus 6, 5. 5 minus 3 is 2. 2 minus 0 is 2. Take note, you can check your answers on the less than CF column. That is by making sure that you have the same value on the lowest class interval for the column's frequency and less than CF. So since the frequency of the lowest class interval is 2, then the lowest value, or the last value on the less than CF column, should be equal to 2. Or starting from the bottom, we have to copy first the frequency of the lowest class interval, that's 2. Then to find for the succeeding less than CF, we have to add the next frequency to the preceding less than CF values. So 2 plus 0, that's 2, plus 3 is 5, plus 6 is 11, plus 7 is 18, plus 9 is 27, 27 plus 6 is 33. 33 plus 7 is 40. Now, since we've completed the table, we're now ready to find for the median class. And to find for it, we use the formula summation of F all over 2. By substitution, the summation of F is equal to 40 divided by 2, so that is equal to 20. Now, to find for the median class, you must look for the values on the less than CF column which are larger than 20, our summation of F over 2 value. Then after that, you choose which among those values is the lowest. So for this example, we have 40, 33, and 27. These are the values on the less than CF column which are greater than our value for summation of F over 2. And the lowest among those values is 27. Therefore, the median class is on the class interval containing less than CF, which is 27. So it's on the class interval 36 to 40. Take note, this is our median class, or in symbols, we have MC. Take note, finding the median class is very important. It will help you substitute values on the formula for median. So now let's solve for the median of the given grouped data. By using the formula, MD is equal to LB sub MC plus summation of F over 2 minus less than CF all over F sub MC times I. By substitution, we have the lower boundary of the median class, that is 35.5. Then, summation of F over 2, it's here, we have 20. Minus the value of the less than CF. Take note, this should not be found on the median class. Instead, it's the value below or less than the less than CF of the median class. So, it's 18. All over the frequency of the median class, which is 9. Times the class size, which is 5. So we have to simplify first. 20 minus 18, that's 2. Now, in simplifying 2 over 9 times 5, it would be better if you multiply first before you divide. Because if you divide first, and then you got an answer which is not exact, then you will have to round off. And in rounding off, there are some changes or errors on the computation. So we have to multiply first 2 times 5, that's 10. Divided by 9, so we have 1.11. So the median is equal to 35.5 plus 1.11, and that is equal to 36.61. So the median of the given group's data is 36.61. Take note, the computed median is found on the class interval of our median class. It's between 36 to 40. Next example. Again, first we have to complete the table. Starting off with the value of I. And I, or the class size, is equal to 5 because we have 34 minus 30, that's 4 plus 1, we have 5. Or counting the numbers on the class interval 35 to 39, we have 35, 36, 37, 38, and 39. We have 5 numbers. Now, for the summation of F, you have to add all the numbers on the frequency column, and that gives us very good. We have 55. Now, for the lower boundary, take note, we use the formula lower limit minus 0.5. So we have 30 minus 0.5 for the first class interval. That's 29.5. Then for the succeeding lower boundaries, we simply have to add the class size to the preceding lower boundaries. So that's 29.5 plus 5, we have 34.5. Plus 5 is 39.5. Plus 5 is 44.5. Then add again 5, we have 49.5. Plus 5 again, that's 54.5. Then another plus 5, that's 59.5. Add 5 again, we have 64.5. Then plus 5, 69.5. Last 69.5 plus 5, we have 74.5. Now, for the less than CF column, let's start this time from the lowest class interval, which is 30 to 34. As what we have said a while back, the less than CF value of the lowest class interval is equal to its respective frequency, and that is 1. So we have 1. Now, for the succeeding less than CF values, we have to add the succeeding frequency. So that's 1 plus 4, so we have 5. 5 plus 5 is 10. 10 plus 8 is 18. 18 plus 9 is 27. 27 plus 11 is 38. 38 plus 3 is 41. 41 plus 7 is 48. 48 plus 5 is 53. 53 plus 2 is 55. Let us check. Take note, the less than CF of the highest class interval should be equal to the summation of F. So since we have 55 here, that is equal to 55 on the summation of F value. So since we have completed the table, let us now find for the median class by using the formula summation of F over 2. The summation of F is 55 divided by 2, so we have 27.5. Now, which among those numbers greater than 27.5 is the lowest? So if we're going to consider the less than CF column, the lowest value, which is greater than 27.5, is 38. Therefore, the median class is the class interval with less than CF equal to 38. So this is our median class. It's on the class interval 55 to 59. Now we are ready to compute for the median of the given group's data. By using the formula, MD is equal to LB sub MC plus the summation of F over 2 minus less than CF all over the frequency of the median class times I. So by substitution, the lower boundary of the median class, it's 54.5. Then, summation of F over 2, it's here. We have 27.5. The less than CF value is the value below the less than CF of the median class. So, it's 27. Then, the frequency of the median class is 11 times the class size, that is equal to 5. Simplifying, we have to subtract first 27.5 by 27, and that gives us 0.5. 0.5 times 5, that is 2.5. 2.5 divided by 11 is 0.23. So our median is equal to 54.5 plus 0.23, that is 54.73. Therefore, the median of the given group's data is 54.73. Now observe that the computed value for our median is not on the class interval 55 to 59. But if you observe the class intervals using the limits, there are some missing values like 59.3, 59.8, 59.7, and so on. But if we're going to use the class boundaries for our class interval, we have here 54.5 to 59.5. And if that's the case, 54.73 is included in this median class. Do you have questions on the median of group data? If you have, don't hesitate to type your questions on the comment section. Let's now proceed to the last measure of central tendency, which is the mode of grouped data. Recall that when we say mode, it's the value that occurs most often in a given data. So to find for the mode of a given group's data, we use the formula MO is equal to LB sub MO plus D sub 1 over D sub 1 plus D sub 2 times the class size, where MO is the mode, LB sub MO is the lower boundary of the modal class, D sub 1 is the difference between the frequencies of the model class and the next upper class. And D sub 2 is the difference between the frequencies of the model class and the next lower class. And of course, the I is the class size. Now let's have examples. Again, we have here the examples we have used in finding the median of group data. So since we have completed the table a while back and found the values for I summation of F and LB column, let's just go through it. I is 5, summation of F is 40. Then for the lower boundary, take note, we subtract the lower limit minus 0.5. So that's 10.5 followed by 15.5, then 20.5, 25.5, 30.5, 35.5, 40.5, and 45.5. Now, find for the model class. To do that, we simply have to look for the highest value on the frequency column. So looking at these numbers, the highest value is 9. So the model class is the class containing that highest frequency. So we have the class with the class interval 36 to 40. So take note, this is our model class. Or in symbol, we have MO. Now, since we've found the model class, we're now ready to calculate for the mode. Using the formula, MO is equal to LBMO plus D sub 1 all over D sub 1 plus D sub 2 times the class size. By substitution, the lower boundary of the model class is 35.5. It's here. Now, for D sub 1, we have to subtract the frequency of the model class by the frequency of the next upper class. So that's D sub 1 is equal to 9 minus 6. We have 3. For D sub 2, we have to subtract the frequency of the model class by the frequency of the next lower class. So we have 9 minus 7 equals 2. So again, for D sub 1, we have to subtract the frequency of the model class by the frequency of the next upper class. While for D sub 2, we have to subtract the frequency of the model class by the next lower class. So D sub 1 above, D sub 2 below. So by substitution, we now have D sub 1, that's 3. D sub 2, we have 2. And for the class size, it's 5. Simplifying, we have 3 plus 2 first, that is 5. Then multiply 3 by 5, that's 15 divided by 5, so we have 3. And 35.5, that is 38.5. Therefore, the mode of the given group's data is equal to 38.5. Now, let's have the second example. We have here the scores of students in their math exam. So like what we have answered in the second example for finding the median of group data, we have the class size 5. For the summation of F, it's 55. Then for the lower boundaries, we have 29.5 for the lowest class interval, followed by 34.5, then 39.5, then 44.5, then 49.5, then 54.5, then 59.5, then 64.5, then 69.5, and last we have 74.5. Now, let's find for the model class. Again, it's the class with the highest frequency. So considering the numbers on the frequency column, the highest is 11. So our model class is on the class with this highest frequency. So we have the class interval 55 to 59. Now let's compute for the mode of the given group's data. We will use the formula MO is equal to LB sub MO plus D sub 1 all over D sub 1 plus D sub 2 times the class size. So by substitution, we have the lower boundary of the module class, that's 54.5. And D sub 1 is taken by subtracting the frequency of the model class, which is 11, by the frequency of the next upper class, which is 3. So we have 11 minus 3, that is 8. Now for D sub 2, we subtract the frequency of the model class by the frequency of the next lower class, that is 9. So 11 minus 9 is equal to 2. So let's substitute now. D sub 1 is 8. D sub 2 is 2. And the class size, of course, is 5. Simplifying the given equation, we have to start with adding 8 and 2. That's 10. Then multiply 8 by 5. That's 40. Divided by 10, so we have 4. And 54.5 plus 4 is equal to 58.5. So the mode of the given group data is equal to 58.5. So take note that our computed value for mode is on the class interval of our model class, which is 55 to 59. Do you have questions? If you have, please type them on the comment section. That ends our discussion on the median and mode of grouped data. But before we end this video, remember that there are 3 measures of central tendency for both grouped and ungrouped data. But in finding for the median of grouped data, we use the formula MD is equal to the lower boundary of the model class plus the summation of F all over 2 minus the less than cumulative frequency all over the frequency of the median class times the class size. And for the mode of group data, we use the formula mode is equal to the lower boundary of the model class plus D sub 1 all over the sum of D sub 1 and D sub 2 times the class size. That's all. I hope you have learned a lot from this video. Thank you for watching.